I am Anil Kumar. Welcome to my series on transformations. In this video, we'll consider transformations on the parent function square root. So we'll begin with understanding the parent function itself and then take up horizontal translations, vertical translations, stretches and compressions, horizontal stretches and compressions. Combination of these, we'll write equation from the graph and we'll see how to sketch the graph of these functions. We have taken questions from previous test papers and I hope that will help you to understand this topic better. So let's begin with the parent square root function, which is shown here. F of x equals to square root of x is the parent square root function. The key values which we always consider for sketching the graph of square root functions can be written as x and y values. We'll write down here where y is equals to square root of x. So if x is 0, y is 0. If x is 1, y is 1. If x is 4, y is 2. If x is 9, y is 3, and so on. So these four values are the key values. Another characteristics which is of our importance is when x approaches positive infinity, in that case y also approaches positive infinity. And that is a behavior shown by the graph which I am indicating now with an arrow. So let me mark the critical points on the graph which we are going to always consider while doing transformation. So 0, 0 is one of them, and then 1, 1, which is right there. And then we have 4, 2, and we have 9, 3. So 9 and 3. So these are the four critical points and the behavior, which is the end behavior. As x approaches positive infinity, y approaches positive infinity. So these are the five characteristics which we will always consider when we sketch graph of a transformed square root function. So I hope this point is absolutely clear. Now with that in mind, let's take these transformations one by one. So we'll begin with vertical translation. As the name suggests, vertical means that either the graph will move up or it will move down. And this really depends on the value of q. So if the value of q is greater than 0, it moves up. And if the value of q is less than 0, it moves down. Simple as that. Based on this criteria, we have taken a very simple but important example, which is graph g of x, where f of x is equal to square root of x, and q value is 2 and q value is minus 1. So basically, we have to sketch two different graphs. So let's sketch them one by one. I'll take different colors so that we could appreciate what really happens when the q value changes. Q indicates vertical translation. So if q is plus 2, in that case, let me write down here q equals to 2. That really means we're talking about a function g of x which is equal to square root of x plus 2. Perfect. Now in this case, it has to move 2 units up, right? So the transformation here is 2 units up. So each point, which is our critical point, we have to consider that. So the critical points were at 0, 0, 1, 1, 4, 2, 9, 3. Now these points will all move 1, 2 units up, right? So that means this goes to this point, 2 units up. Here, we'll have this point right at 3 instead of 1, 1 plus 3. 2 plus 2 is 4, so we get this point here. And the point here is 9, 3 plus 2 is 5. So at 9, we are going to get 5. So the graph, which I'm now connecting these points, is like this. And the arrow at the end, right? So that becomes your graph. Is that clear to you? Let me just make it bold. Okay. So that becomes the graph of our transformed function. So that is how it should be. Now that means simply any point you consider, we are just moving 2 units up. So plus 2 vertically upwards. Clear? Now let's take up the next one, which is q equals to minus 1. So if I am saying q equals to minus 1, in that case, the function g of x can be written as square root of x minus 1, right? Minus 1. That means it will be translating 1 unit down. So that means we have to consider the parent function and these critical points, it goes 1 unit down, right? So it goes 1 unit down and we get our image points. The points which we are trying to get now here are called image points, right? So these are the new image points. We'll connect these image points to get a graph, and that becomes the function square root of x minus 1. So I hope you're getting the whole concept. So that is how we can straight away sketch the graph from the graph itself by translating the graph by the number of units of q, and you get it. The other way to do is you could also think about writing the points themselves. So now let me write down the key points and then we'll do the translation. So the key points for the function are, as we had been saying, 0, 0, 1, 1, 4, 2, 9 square root is 3, and then when x approaches infinity, y also approaches infinity. So these are the key parameters which we are always considering. Now in case when we do for q equals to plus 2, in that case the y values change, and what we get here was x value remains same 0 and the y value becomes plus 2. Do you see that? And in this case 1 and 3, and there it becomes 4 and 4, and in this case it becomes 9 and 5. And when x approaches infinity, y approaches infinity, remains same, right? Infinitely large amounts, if you add some value to it, it doesn't really matter. As far as the other graph is concerned, we see that the new set of points will be, instead of plus 2 in the previous case, now it is minus 1. So it'll be 0 minus 1, and then it'll be 1 0. We are subtracting 1 from the parent function points. Is that clear to you? And then we have 4 1, 9 2, and when x approaches infinity, y will approach infinity. So those will be our critical points to consider to sketch. You can plot these points and then connect. So that is the second method. You can go from points to the graph, or you can just trace the graph back. So any of this approach could be adopted. So let's look into horizontal translations now. So in this case, we have horizontal translation since the function is g of x is equal to f of x minus p. The transformation is within the bracket. Whenever it is within the bracket, it is always horizontal. Clear? Now, in case 1, if p is equal to 2, in that case, our function g of x can be written as x equals to x minus 2. Is that clear to you? So that gives you that the function translates 2 units left. So in this case, the transformation is translate 2 units right. 2 units right. What makes this 0? So the question which you should be asking is, what makes it 0? Plus 2 makes it 0. So it translates 2 units right. So again, let me write down the key points and then we will see how these key points will get translated. So I'm writing the key points here for the function and then we will use for both. So the key points are 0, 0, 1 1, 4 2, and 9 3. And also the end behavior, which is when x approaches infinity, y approaches infinity. Since there is no reflection, that remains the same. So end behavior only changes when there is a reflection. Is that clear to you? Okay. Now, if those are the key points, we are actually changing the x value now, not the y value. So x value 2 will be added. So in this particular case, if I have a point xy, it will change to x plus 2, y remains same. Is that clear to you? So now the key points will be, we are adding 2 to the x values. So it will be 2 0, 3 1, 6 2. The y values will remain same, 11 3. Does make sense to you? So we'll plot these points this time. So we are taking a different approach. We took a different approach last time. It's another approach. It's good idea to understand how we could approach a question. So the new points, transform points, image points will be 2 0. Then at 3, it comes to 1, which is here 3 1. 6 2. At 6, it becomes 2. And then 11 3. So the value of 3 will now be slightly ahead of this, correct? So we're just putting this. Connecting these points, we get a graph, and this is the graph for the function. Is that clear to you? So that is how we are going to sketch this particular graph. Now let's consider the second graph, which is for p equals to minus 1. If p is equal to minus 1, let me write minus 1 here. In that case, the function g of x can now be written as square root of x minus and minus makes it plus 1. So in this case, we are translating 1 unit left. So I'll use the second method of sketching this time, not the points. So we'll sketch by graph, right? So we'll use graph to sketch. Graph transformation, that's what I mean. Okay, so we'll move each and every point just 1 unit left. So 1 unit is right that much. So we'll move from the parent function 1 unit left and get our point. So the critical points are being moved 1 unit left. Do you see that part? Now this point will be moving here. So we get a new point here. And 3, which was at 9, will now move to 8, correct? So these are the points, and we can now sketch this function. So that becomes the second function, which is square root of x plus 1. Is that clear to you? So that is how we get our function. Now, as an additional question, what you could do here is you could write domain and range of these two functions. So the question for you is write domain and range. You see domain changes in this particular case. So I'm writing domain and range for these functions. Is that clear to you? So that will be a good practice question for you. I hope you have understood these steps. Now, we'll combine some of these steps later. First, let us look into the vertical stretch and compression and also reflection in this particular case. So now we have to graph g of x where f of x is square root x and the value of a is given to us as 2 and a is equals to minus half. So there are two different values of a which will result into two different cases. So we'll take these cases one by one. So let's take the first case where a is equal to 1, a equals to 2, right? So that is the case which we are taking. In that case, the function g of x will now be equal to, so a is 2, right? So we'll replace this by 2 and f of x is square root of x. So that is how we are getting our function, which is 2 square root of x. This really means that the graph is stretched vertically by a factor of 2. So we'll write this vertically by factor of 2. That really means that if you're considering the original points, which are 0, 0, 1, 1, 4, 2, and 9, 3, in that case, when the new image points will be, the y values will be multiplied by 2. So 0 remains 0 for y value. However, 1 becomes 2, and 4, 2 times 2 is 4, and we get 9, 6. So that is what we mean. So those are our image points. Do you see that? So we can now plot the image points and then sketch the graph. So 0, 0, 1, 2. So at 1, we have a value which is 2. At 4, it becomes 4. So at 4, it becomes 4. So it goes kind of outside our scale. So we'll kind of limit there. Connecting these points will give you the graph of the transform function. Let me sketch like this. Is that clear to you? Clearly, what you observe here is that there is a stretch. So every point doubles up. This was at 1, it goes at 2, but the 0 times anything remains 0. So that remains, and the point which was at 2 will move out to 4. Is that clear to you? So that is what we mean when we do vertical stretch. So the graph becomes narrower, right? So in this case, we have a narrow graph. Now let's take up the second case, which is when a equals to minus half. So if a is equals to minus half, in that case, g of x will be equal to minus of half square root of x. Now in this case, there are two transformations taking place. One of them is reflection on the x-axis. So one is reflection on x-axis and the other is compression vertically by half. So these are the two transformations which take place. So for these transformations, what we are doing here is that the key points, which were these, the y values, will become negative and half. So in this particular case, the key points will be, let me write down here itself, the key points. The key points will change from xy to the x values remain same, the y values become negative half of original values. Is that clear to you? So which will result into the new points, 0 remains 0, the other 1, 1 becomes 1 minus half, right? The 4, 2 divided by 2 is 1, so minus 1, and 9, 3 divided by 2 minus 2 will be minus 4.5. So those will be the new points. So let me use a different ink to sketch these points. So I'm using green color now, this particular ink, to sketch these points. 0 remains 0, so we'll just put 0 there itself. 1 minus 2. So at 1 we have a value which is minus half. So at 1 we have a value which is minus half right there. At 4 we get minus 1. So at 4 we get minus 1. At 9 we get 4.5. So at 9 we get sorry, half of 3. Half of 3 will be 1.5. Okay, so 1.5. So 1.5 will be there. So the graph which you see will be kind of like this. Does make sense to you? So that will be the graph of our function. So let me just make it thick so that it is easily seen. So these are the new transform points, and that is how you get them. So I hope it is absolutely clear. Now, let us look into the next example where we have horizontal compression, reflection, and stretches. So in this case, we are considering the function g of x, which is equal to f k of x. We need to graph g of x for the function f of x equals to square root x. The k value this time is half and k is equals to minus 2. So let's take the value of k as equal to half first. So in that case, the value of the function g of x can be written as equal to, since k is half and that is the function which we are using, it will be written as square root of half x. Now that really means that the graph is being horizontally stretched by a factor of 2. So it is horizontally stretched by factor of 2. So that really means if I identify my original points, which are 0, 0, 1, 1, at 4 we have 2, and at 9 we have 3. So these are my critical points. So I'll go straight from the graph this time. What is happening is we are stretching. So what is happening here is that we are stretching horizontally by a factor of 2. So 2 times 0 is 0. It remains there itself. But the point which was at 1 becomes 2. So it stretches. Do you see that? So it becomes here. The point which is at 4, it stretches to 8. 4 times 2. And the new graph will be this. Is that clear to you? Now let me write down the new values for the transform function. The key values which we had been always considering are, let me write down here, 0, 0, 1, 1, 4, 2, and 9, 3, right? So these are original xy values, correct? Now, the transformed values will be, the x values will change, they double up. So first one remains 0, 0, the second one becomes 2, 1, and then we have 8, 2, and this will become 18, 3, right? So these are the new values which we have plotted here to get our function. So that was the second way of doing it, right? Now let's look into the second part, which is when k equals to minus 2. So if k equals to minus 2, in that case, g of x can be written as square root of minus 2x. Now here there are two transformations. The first one is the reflection on y-axis, and the second one is horizontally compressed by factor. It's important to write the term factor because you're multiplying it by half, correct? So I'll show you the two transformations this time. One is reflection, correct? So when it gets reflected, these points, well, while the 0 point remains at 0, the point which is at 1, it will actually come to minus 1. So that is the reflection, right? So that is the reflection. So this is the first thing which happens. And then it is getting horizontally compressed. So in the second stage, it comes to half the value. You get an idea, right? So this point here will first get reflected. So instead of being at 4, this will get reflected to minus 4. So we have a graph which will be kind of like this. So this graph is of square root of minus x. So that is the reflection part. So we have done the reflection in this case. Now, let me draw the final one, which includes compression by a factor of half. So the compression will be that the point 0 remains at 0. However, all these values will come halfway. So instead of 4, this will be now at 2, minus 2, I mean. And instead of 9, this will be at 4.5. So this point here will be at 4.5. So it'd be kind of here. So connecting these, we incorporate the compression. Now we get our function which is square root of minus 2x. Is that clear to you? As far as the image points will go, the, the xy values of the original function will now become, the x values are, in this case, minus half of the original values, the y values remain the same. And therefore, the new points will be 0, 0, and then we have minus half, 1. So we're just doing on these values, right? The original values. Half of 4 is 2 with a negative sign. The y value remains same. Half of 9 with a negative sign is 4.5. The y value remains same. So those will become the new or the image points for us. As you can very clearly see, the domain and range changes, right, in this particular case. So, so what you could do now is write down domain and range for this particular function. So as an exercise for you, I'm writing a question here, write, write domain and range for g of x. And second thing, which is very important to understand here, is that when we do reflection, you see the end behavior changes. So what we also notice here is that when x approaches negative infinity, then y approaches positive infinity. And that is happening because of this factor, x is getting multiplied by the negative number. And so instead of the original function, the end behavior was when x approaches infinity, y approaches infinity. So this term, infinity, has been multiplied by a negative number. So what we get here is this. Do you get this idea, right? So this was very important change which is to be noted for reflection on the y-axis. Perfect. So I hope with this you have understood the concepts. Now, based on this, I would like you to take up the test questions. Here is the very first test question for you. You can pause the video, copy the question, try it out. In next part of this video, I'm going to provide you the solutions of these test questions. Question is to describe the transformations and sketch the graph. Now we will do it in two ways, and that is why we have question 1a. This time you describe and then do it graphically. And the second part is describe the transform and sketch the graph, but use key points in this particular case. So find image points and then graph. Is that clear to you? So use two different methods. Question number 2, again another square root function. However, this time we are now focusing on the horizontal transformations, both stretches and compressions, and translations and reflections, and the vertical translation. So in this case, we have given you the table. So fill in the table and then use the points to sketch. And in part B, I would like you to sketch it using the technique of graph without any calculation of the points. So you can pause the video, copy this particular equation, and then you can submit this assignment. Here is question number 3. Now in question number 3, you have to write the equation from the graph. So a square root function graph is given to us. You need to write the equation from the graph. The key point to consider is the very first one that will give you the translation and probably the equation of the graph. And the last question here is a thinking question where we have incorporated both reflections, translations, kind of everything is there in this. So in this particular case, you need to focus on what you have learned in this particular video to write down the correct answer. So I hope you find all this interesting. We have incorporated almost everything about transformations which have been applied on square root functions. So in general, I like you to add a question to what we have done, and that is to describe end behavior of all these functions, right? So I like you to describe the end behavior of all the functions which you have done in this particular video. So that will really help. And also you could look into how the domain and range changes with transformation. that will give you better insight to transformations. I hope it makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.